Okay, let's take a look at the 3 questions you had for homework. Number 13 says, continuing their bike ride, so this is a continuation of the story from the earlier questions. Jasmine and Jonah coast down. Sorry, I thought my iPad stopped. Jasmine and Jonah coast down a long hill that leads to the river valley. They accelerate at 0.12 meters per second squared. They accelerate. I'm giving you the acceleration. 0.12 meters per second squared for 85 seconds. That's the time. 85 seconds. And at the bottom of the hill, they're traveling 12.1 meters per second. So that's their final velocity, 12.5 meters per second. And that 85 had 2 zeros on it. What is their initial speed? So you're looking for VI. Okay, so we're going to use the equation. A equals VF minus VI over delta T. And you want to get the delta T by, you want to get the VI by itself. So you first have to get rid of the delta T. So multiply both sides by delta T. So it'll be A delta T is equal to VF minus VI. And now you want the VI alone. I would probably add VI to both sides to bring it over here, and subtract A delta T from both sides to bring that term over here. So you're left with VI equals VF minus A delta T. Now that's the same as if you had subtracted VF. If you subtracted VF, just as an aside, it'd be minus VF plus A delta T equals minus VI. And then you could multiply everything by -1. So VF minus A delta T equals positive VI, which is exactly what you have here. Okay? I just tend to always take my VI to the side, my unknown that I'm trying to solve for, to the side, so it's positive. So that's why I did that in the first step. Okay, so now we can fill our numbers in. So VI is equal to VF is 12.5 meters per second minus A is 0.12 meters per second squared, and the time is 85 seconds. Okay, so VI equals 12.5 meters per second, and 85 seconds times 12.12 is 10.2 meters per second. Because one of the seconds cancels, subtract this, and you get a VI to equal 2.3 meters per second. Okay, so that was their initial velocity. Number 14 says, as they travel at this speed, the 12.5 meters per second from the last question, so that's their VI in this question. As they travel at this speed at the bottom of the hill, they notice a tree across the path in front of them. Jasmine applies the brakes immediately. So for Jasmine, she applies the brakes immediately, and it takes her 2 seconds to stop. So her delta T is 2 seconds to stop. So the VF is going to be 0. But Jonah, still recovering from his earlier fall, is slower applying his brakes, and 0.5 seconds passes before he actually hits the brakes. So he wastes 0.5 seconds realizing, wait, there's a tree across the road. But he still manages to stop at the same time as Jasmine. So if he applies the brakes 0.5 of a second after Jasmine, but still stops at the same time as Jasmine, then his time must be 1.5 seconds. 0.5 seconds slower. And it wants to know what is each acceleration. So for Jasmine, it'll be A equals VF minus VI over delta T. So A equals 0 minus 12.5 meters per second over 2 seconds. So A will equal negative 6.25 meters per second squared, where this negative means slowing down because there's a tree in the way. Okay, final answer for Jasmine. For Jonah, exactly the same equation, VF minus VI over delta T. A is equal to 0 meters per second minus 12.5 meters per second. There is a point there. And this time, though, it's only divided by 1.5 seconds. So that's like 25 divided by 3. So 8.333 repeating meters per second squared. It's also negative because he is also slowing down. So Jonah's acceleration needs to be bigger because he has less time to stop in, because he wasted 0.5 of a second evaluating the situation and realizing, oh, maybe I should stop. Number 15, you are traveling 80 kilometers per hour, and it's you in a car. You're not on a bike with Jasmine and Jonah. So your VI is 80 kilometers per hour, which we have to change to meters per second. So 1,000 meters in a kilometer times 1 hour, 3,600 seconds. You should get a VI of 22.2 repeating meters per second. Okay, so that's your VI. When a deer jumps out in front of you, you apply the brakes. It takes you 2.5 seconds to stop from the time you first spotted the deer. Okay, so you're in a car, and warning, here's my deer. The warning is it's kind of a sad deer. So the deer jumps out in front of you, and from the time you see it till you get stopped, it's 2.5 seconds. But it took you 0.75 of a second to actually hit the brake. So you're driving along, and you're like, oh, look, a deer just jumped out on the road. Oh, isn't it pretty? Look, it's pretty big. Oh, man, it's not moving. Maybe I should stop. So it takes you 0.75 seconds to decide to stop, and it takes you 2.5 seconds from the time you saw it until you were stopped, which means the brakes have 1.75 seconds to act, right? So 2.5 seconds total, but you waste 0.75 of it. It's called your reaction time. So the time the car has to stop in is 1.75 seconds. It's stopping, so VF is 0. And the question wants to know, what is the acceleration? So A equals VF minus VI over delta T. A equals 0 meters per second minus 22.2 repeating meters per second over 1.75 seconds. A equals 88 divided by 7. 12.698 meters per second squared, and it's going to be negative. You're stopping, you're slowing down. Okay, so hopefully these ones went pretty good. That is the end of those questions. Now the next video will do something new, but you also have an assignment to work on. Let's do the next day I see you.